So today demos will go with respect to what is DevOps and what are the roles and responsibilities of DevOps and what tools we have to learn with respect to DevOps. Okay, I'll show a little bit demo. Okay, at the same time, who are all using DevOps today? Maybe we discuss a little bit. Okay, I think most of the audience know about testing. Correct? You're all from testing perspective. I didn't hear anybody from the development side or only operations side. Of course, server I heard, but development side nobody heard here. Fine. Let's move on. First of all, we should know what the release process, software release process, SDLCs. Since each and every person in this group mainly working on the testing and then the server maintenance, all those things. Basically, of course, we know the SDLC process right from requirements to till deployment and maintenance. Correct? Each and every process will have a lot of pages as well as a lot of process and a lot of groups are involved in this. Say somebody asking, I need resource for the project, or can you change the requirement of this project? I'll say yes. And how much time it will take, how it is going on. That is what actually process. So here in release process we have, I'm talking the release process now. Everything is agreed now. Project is agreed. Requirement is completed. Everything now. Start coding. Check in source coding, peer reviews, new code, new version controls, all those things. And then build, compile the code, unit test, checks and everything. And then testing, finally production. This is what release process of a software, not SDLC. I'm talking release management activities, release manager process. Basically, once team is finalize the requirements and everything, that start development and then checking the source code, peer reviews, version control. Once the coding development completed, we have to start building and then checking of the core standards as well as the unit test results and all this stuff. Finally, integration testing, different systems, integration testing, and then production. Production, nothing, deployment in the production as well as this process we know very well. In this process, see, every process is involved here, each with respect to each group. Source management group, peer reviews. Who is going to do peer reviews? Peer reviews is going to do seniors. Development happening, multiple people are developing there. And just checking the code is there, one part, everybody is checking the code. Correct? And then somebody has to resolve the conflicts also. We'll see what conflicts meaning. Once that is done, source code is ready, now build. Build, who is doing again? Build will do again. Once the coding standards verifications and then styles verifications and then all standards verifications, people will do building. While doing building, we'll get a lot of warnings, maybe errors also sometimes. These are not runtime errors, these are the build errors. So once I build it, again, this is another group is there, another person will be there in this. Once I build, QA testing will be there, unit testing, load testing, performance, and so many testings we have today. This is another group involved here. Finally, production is there. After production, operations team, it will go for maintenance. If you see in this release process, within each process itself, we have verification step. Correct? Build it, test, and verify it. If some errors are there, suppose example, take first source control. The moment I check in the source control, a lot of conflicts will be there with respect to same class names or same file name. File name already exists. Those are conflicts. At the moment I'm testing there. So I have to resolve these conflicts. That means if something same, suppose I'm using same file name, some test class.java, somebody using same class name like test.java or same Java db.class.java. That means I have to coordinate with that guy, boss. I'm using same class name, with file name, you're also using same file name or same class name sometimes. Somebody has to change this. That's the first part. So each phase we have activity, and then verification of activity, and then if you find any issues in the activity of verification, resolve this. 3 steps are there. In the build also, we have same thing. While I'm building, I'll get some errors. So I have to go back to the corresponding development team, boss, yeah, I'm getting this error while building it. Can you see the errors? Again, they'll modify the code, check in the code, and it will again test. Testing also same. QA will test it, like raise the bugs, and then development team, and then come back. So what I'm saying here is, production also same, deployment. Once I give the installation document and then package to the deploy, because there is separate team will be there. It can be separate company or to a separate team also. While they are deploying, they say, I'm getting some error while deploying. So if you see, everywhere it has certain processes as well as groups are involving. In this process, what is happening actually, development team is involving, operations team is involving, and then a lot of communication is happening there between these two. Everywhere it is happening, a lot of communication. Each place we have different groups and then a lot of communication, collaboration, and integration should be there. So because of everybody have their own world, nothing but development team says, yeah, it is working for me. Developer says it works for me because it works in his laptop. But while I'm doing building, I have to build entire all developers code. So there I'm getting error. At the same time, entire development team saying it is working for us in deployment in a local server. But I'm give to the production server, it won't work. Maybe difference of the configurations, all those things. So there's always wall of confusion is there. Because of this wall of confusion, what is happening completely? It is blasting in the production. Deployment not happening. So the operations team says, deployment said, boss, we want stability of your code. Development team saying that I want this change to be pushed immediately to the server. Because customer is asking, is waiting for us, waiting this code to be deployed in the production. But things are not moving. Only pushing and is happening. Like is revolving the ball. Finally, what is happening? Waiting, write code, build code, and deploy everything. So it is minutes, days, and then weeks. Finally, what is happening? End user is getting impact of this. Correct? This is what happening actually in IT. Till 2009 and 10, this is a case. Most of times, everybody we work with isolates. Like nothing but actually, who is giving requirement is one team, nothing but end users. That end user will give requirement to business users. Business user will give the requirement to IT team. IT team will give to the developers, nothing but vendors. And then development team, once they develop, everything works fine, and then try to push to the deployment team using the production deployment teams. But nothing is happening. Finally, ultimately impacting to the end users. This is nothing but actually a process completely. If you observe here, I didn't talk any technicality here, correct? I am using only process words here, just to explain the process. Now, so because of taking months and years or days, depends upon the volume of the work, small change itself, it is taking a lot of time. The customer is not able to do their business because of change is not happening in the software. Now, to avoid all these things, people come up with some process. See, DevOps is not actually a software. DevOps is a process, release process. Okay, DevOps is nothing but a release process. To enable this process fast, people found the tools. Now, in this process, okay, first they came up with a continuous integration. Once they check in the code by the developer, the code should automatically build automatically and give the error report immediately to the all stakeholders. All stakeholders, nothing but entire development team as well as the architect team, everybody. See, error can be because of design, error could be because of the coding standards, error could be because of the naming calling standards or conflicts or so many other things, integration stuffs, correct? Now, to avoid all these things and reviews, code standard reviews, because I told coding is developing by the 5 years, 2 years, 3 years guy, but actual reviews are doing by the 10 years 10 years experience or 7 years experience guy, or maybe freshers are doing the coding and 1-2 years experience of doing peer reviews, and few warnings also may be there. Suppose if you take, there is no errors, but I'm getting warnings because of some function may be absolute. I'm using one function, one method, either Java or .NET or anything. It could be anything, even SQL also. But that method is absolute in coming in new versions. So warnings will come. Sometimes what happens, if you have more than 100 warnings, the build will stop. If you have more than 20 warnings, depends upon the technology using, the build automatically stops. So to avoid all these warnings as well as peer reviews and then integration stuff, so there is a concept here, continuous integration. Continuous integration, nothing but individually who is developing, and then all the developers code should integrate automatically and make it a package ready for the deployment. That is called CI process. Here also I'm not talking any tools, just I'm talking about the process. Continuous integration process, nothing but actually checking the code from individual developers and then verify the code standards as well as the configuration part, and then conflicts of the resolutions with respect to uses of the same names and then everything, and then warnings fixing automatically and build it. Once this is built, that means my package is ready now, deployment. Where I have to deploy? I have to deploy in one server, correct? But before deploy, there are two steps are here. Testing process are two steps. One is actually unit testing. Who is doing unit testing? Unit testing has to be done by the development team, developer. Okay. Individual developer has to do unit testing. Once unit testing completed, then somebody has to do integration testing, entire package. Once integration test pass, then we'll give to the UAT. There's a process in testing. Testing itself, we have phases. One is unit testing, nothing but developer has to test at each component level. Each component, nothing but actually each text box level or each selection box, each radar button, each button level has to test everything working or not. After that, the complete scenario flows with testing in the SAT, system integration testings. There's other team, business analysts and other teams will test it there, including all scenarios working or not from one screen to another screen flows, not only within the screen, one screen to another. Suppose I'm logged in. So my login ID details are displaying in each screen, yes or no, my name and then my number, maybe a few details, my mobile number, all those things. If you take MSN, once you logged in, it will display there your name and then account details. Correct? The account details coming from the login details. So that is nothing but integration between two pages testing. Similarly, after doing that, UAT testing will be there, orders and everything, end-to-end flow, and then performance testing will be there. How many users can log in at a time with a single server? Or do you need to? So many test cases are there. So many tests. Once pass all these test stages, every test if it is within the tolerance limit, and then only people will go for the production. So this is the process of the release process, correct? Now the next step is continuous delivery. What exactly meaning of the continuous delivery is? It is nothing but actually source and then build is continuous integration. Once I build, I have to deploy it someplace to test it. Either it could be SAT environment, it can be UAT environment, it can be anywhere, correct? And then before deploy to production, everything I need to test. So continuous delivery is nothing but actually CA and then test is nothing but a continuous delivery. Finally, we'll have continuous deployment. So the combination of CA plus CD, nothing but CA and nothing but actually continuous integration and then continuous deployment and continuous delivery. Continuous delivery equals to actually continuous deployment and continuous integration. So to get continuous delivery, we'll use some tools. That figure it is showing actually tools to be used. Gate should open there. And of course, once it is passed, somebody has to verify, yes, these are test cases passed. Or test, even though I'm saying testing will be there, UET testing, SAT testing, load testing, but somebody has to review these test results. So there will have the toll gate. Toll gate nothing but actually some workflow will be there. Before deploying to production or before going to UAT, SFT test case should pass. At least 95% of test case should pass. 5% tolerance can be there. I can live it. Similarly, somebody has to verify. That time we will have the workflows. So DevOps is nothing but actually is only the process, completely process. To enable this process, we'll use different tools. Now, people saying Agile and then DevOps, both are different, or what is this difference between these two? So both are not technical, both are only process. As I said earlier, in release process, we have testing, build testing and verification and error verification, correct? All three we are having at each stage. Agile is saying nothing but actually do this part everywhere. Test, review, and then cycle. Develop, test, review, and then again fix it. And then develop, test, review, and fix it. That is what Agile. But DevOps is not nothing like that. So DevOps actually the stakeholders between communication between the stakeholders, nothing but actually customer requirements, development and testing team, and infrastructure. These three teams are involved. Okay, Agile is nothing but actually the gap between, it builds the gap between the requirements and the development team. Nothing but actually earlier we used to use traditional way. Oh, it used to take 1 year to writing the SRS and then BRD. Nothing but system requirements, use cases, all those things. So it is taking a lot of time. So that gap is built by Agile. But still, two more steps are there, and testing and then moving to infrastructure. So DevOps builds the gap between development team as well as the operations team. That is the difference between DevOps and Agile. Agile is building the gap between actually Agile customer as well as the development team, and then DevOps building the gap between these two. The combination of Agile and then DevOps tools is building the gaps end to end. That is nothing but end to end delivery. So we have a lot of tools in this scenario, which building the gaps between the Agile gaps, nothing but gaps between two parties, customer as well as development team, and then DevOps, nothing but actually operations and a gap between developers and operations. Now, the principles of Agile, DevOps, of course, Agile we have different principles, but the topic today is DevOps. So DevOps principles are customer-centric actions. We'll see one by one. I'll explain one by one. End-to-end responsibility, and then continuous integration, automate everything. Of course, we discussed. Monitor and test, and then work together as a team. That means remove the gaps. What is meaning of customer-centric actions? So what exactly meaning it is? In traditional way, we should have a traceability matrix. The traceability matrix is nothing but actually, if customer gives one requirement, take example login. Okay, log into website or log into application. Once I log in, okay, for this login, what is my use cases? Use case nothing but who can log in. That means normal user can log in, admin can log in, IT operations can log in, and maybe CEO can log in, CEO can log in, different people can log in, nothing but different roles of login. Each role can see different menu. Normal login can see only the few menus. Operations team can see login, can see error logs also, some reports. Admin can see all the screens, and then he will have different roles. So the customer center nothing but actually once I build the requirement, and depends upon the requirement, what are the use cases, how many flows are there. That's first step. Second step is once this flow is done, okay, what is the design component of this flow? Each flow will have different design component. Okay, what are the design, technical design component is covered or not technically? Once technically covered, this is where is my component build? That means where is this code is there, which file or which module it is there. Login module, which is a login module, where is this code covered into admin module or some other module. That is another part. One that is covered, where is the test case for this one? Test scenarios, test script, test IDs. One test script is develop test results. Where are the unit test results, SCT test results, UAT test results, and finally whether it is deployed or not. This will be tracking. Track will be there in one sheet itself. All will be tracked. That is called accurate traceability matrix. Nothing but fund requirement given to the customer till the production. Where it is deployed, which server is deployed, when it is deployed. These will be there. So this is a customer-centric process. Customer can trace the, once he gives the requirement, where it is now. Where is the requirement with respect to deployment, or with whom it is pending. That is a customer-centric actions. End-to-end responsibility. So in this scenario, while we explain the process, the code is rotating to each group, correct? Initially development team, then testing, and then everything. Everybody has to take responsibility whether this is passed or not. Okay, whether this is completed or not, or I'm getting any error. End-to-end responsibility should take by everybody. Okay. Continuous integration automate everything, nothing but actually seamlessly. If some changes comes, example, today I put actually in one screen, one logo. Okay, logo changed. Okay, or take example of the analysis of the coronavirus. Coronavirus analysis coming today. Correct? Everywhere, state-wise, everywhere coming. Okay, but worldwide coming. If you see a lot of analytics developed automatically, data is feeding automatically. When now data is feeding different state, different distance, different worldwide, data leading to the feed worldwide. So a lot of people develop a lot of analytics. How it is happening? Everybody have their own data source, but data is showing as a single source there. So once somebody change data seamlessly, my graph is changing automatically. So that is continuous integrate and automate everything. It is not like manual feeding data there. And monitor test. Monitor test means here, okay, whether the server is running or not, what is the health check, how much memory left out, how much CPU is running out, is everything working fine or not, with respect to systems, with respect to application, with respect to functionalities also. See, functionality should not break. That is the most important. Applications should not take more performance. At the same time, should not consume the logs. If you're creating a lot of logs should frequently archive there. Or maybe data should be archived there automatically. Application logs, server logs, so many are there. So those are all automatically should done. Health checks are the thing. Finally, everybody should work as a one team. So for any questions in this process, till now explained only process. Correct? Just ping if you have any question, just ping. We'll take questions. So now what is DevOps? Everybody's saying DevOps. Till now we discussed only the principles and everything. But outside saying, yeah, if you know the DevOps, you are the excellent engineer in the end-to-end. Now if you see here, I discussed about DevOps, development as well as the testing, of course, design, testing, and then deployment. So if you want to become a DevOps engineer, actually, you should know all these three things. The center of all these three groups should be the DevOps engineer. So let's see roles and responsibilities and skills DevOps engineer. What are the roles and responsibilities and skills of a DevOps engineer? DevOps engineer not only testing, not only development, not only deployment. You should have knowledge on the deployment. You should knowledge on the development. You should knowledge on the testing. But is it possible to have one person to have all these things in current industries? That is a question mark. Correct? Because whatever opportunity we're getting in companies, we work only in that. Suppose if I'm getting opportunity as a testing, I will become tester. I can become expert in tester. But I may not become I don't know development team, I don't know how to deploy also. But I'm an expert in testing. I'm 200% expert in testing. At the same time, operations team, I'm expert in Linux servers deployments and expert in Windows server deployments and deployments of the database. At the same time, development team, they don't know how to configure the servers. They don't know how to deploy, but they may be expert in the writing excellent code without single bug. So these are all isolation person, but the ultimate develop engineer should know actually all these things. Okay, all these things they should know. Just now we discussed about the traceability. So increase the project visibility throughout the traceability. That is one part, and manage the effectively standards. Whatever we discussed so far. The final thing for the DevOps is, if you see the 7, 8, and 9, analyze, design, evaluate automation script systems. Okay, ensuring critical resolution of systems issues by the best, of course, any solution, not only cloud, for that matter, anything. Okay, and software should be there for the analysis purpose and getting more information from the all three teams. If you see the second, third point there, able to perform systems troubleshooting problems on across platforms and application domains. The word is important is across platforms and application domains. Just now I discussed, DevOps engineers should know development thing, testing thing, as well as a deployment team across the platforms. Now, in industry, since it's not possible, people evaluated the tools. That is where tools came actually. Of course, as a one team, should the goal is everything should be one team, the wall of convention should remove. For these things, people evaluated the tools. Different tools are there. So because of tools are implementing there, the time is get reducing as well as it is going out. Now automation tools. We have different tools are there. The tools for actually, we have infrastructure building. What exactly meaning of this infrastructure automation here? Suppose I want to build 120 servers or 70 servers or 20 servers for my production. Take if it is a big project, Amazon project, worldwide project, or some bank, Citibank, or some bank, any bank, global bank. So I have to deploy a new project for them. Is one server sufficient? No, because global usage is there. So because of performance issues, I had to build 20 servers. How do I build 20 servers? It will take a lot of time to build 20 servers because I had to purchase hardware, I had to install the OS, I have to set up the software requirements for the application and then deploy the application there. So each person will take minimum 1 to 3 days. So if each person is taking 1 to 3 days, when my deployment will go, it will take at least minimum 2-3 weeks, minimum, bare minimum, once infrastructure ready. So to avoid this concept of the time lagging there, infrastructure automation came. That infrastructure automation nothing but actually building the servers with a small configuration script. That is nothing but actually we are calling earlier, we actually ghost image. If I build one image, VMware came. VMware concept came only because of that. VMware came and Ghost came because once I build one server, I'll take image of that server. Then I put the same image in all the servers quickly. So no need to again wait for the hours together for installation. That is automation of the infrastructure. So code as the infrastructure, that is called. I'm doing some scripting there, or I'm using some tool to build the image and then building as infrastructure. That's called code as an infrastructure. And configuration management. Again, configuration management nothing but actually once infrastructure is ready for development, now I need to put my source code. Where I have to put my source code? Hundreds of development team members are there. Maybe 10 members are there, 20 members are there. Depends upon the volume of the project. It can be 5 members team, 10 members team, or 20 members, depends upon 10. 100 also sometimes globally. One team, one module team in Singapore, one module team in US, one module team in UK, and one module team in India. But how to coordinate among all these things? That is nothing but actually configuration management. Again, configuration management, we have a lot of tools. We have GitLab, we have SVN, we have Collaborate, we have Jira. See, earlier I discussed the process. Each process has a tool. Individual tools are there. Okay. Now deployment automation. Now code is configured now. Now our deployment I need to do automation. Deployment nothing but before deployment I have to build the code. Now we will enable the few tools for the build. Depends upon the technology of the project. If it is .NET, we'll use the .NET build. If it is .NET within the Windows application, different build tool is there. If it is .NET web application, different tools are there. Similar for Java also same. We have so many tools are there. It can be Ant script, it can be TFS script, it can be anything, or it can be normal some people will write big scripts also, but it can be automatically build it. So tools are in there, or somebody can write PowerShell script, somebody can write shell scripting. So all those things should happen automatically. So everywhere I have the automatic tool is there. One that is done, performance of testing, performance testing as well as the verification of the servers, application servers, all those things. Sorry. They also have few tools, monitoring tools are there, a lot of monitoring tools are there. So next, log management. If any issues comes, log management and the revelation. So everywhere we have tools. Now I listed out here few automation tools. Okay. Earlier I told we have Ghost tool is there, as well as VMware is there. Of course, nothing but data centers creating VMware for different servers. Suppose I'm asking I need Linux server with 4 GB RAM for my purpose of the deployment Python code or PHP code. Example. So your data center, your enterprise level, every company will have certain list of approved softwares at the enterprise level. I cannot use my own software. If I am working for one company, nothing but for say, take example, I'm working for maybe SBI Bank or ICICI Bank. SBI, ICICI Bank, their IT will fix, okay, these are tools we have to use within the SBI. They'll fix it. Either it can automate, you can do it, or manually want to do it, but these tools. So if SBI using like Jira for their project management tool, I cannot go and, okay, I want to use MS Project, Microsoft Project Server or a Microsoft Project MPP tool. I cannot recommend. If any tool is coming to any industry, any company level, their enterprise audits, their enterprise security level, their enterprise financial levels, everybody will, legal team, everybody has to verify it. Can we use this tool with respect to security point of view, with respect to license point of view, with respect to maintenance point of view, with respect to legal, if it's open source, what is the legal activity? Can I use only for development or can I use for the production also? Without license, I cannot deploy it, even though we have a lot of pirates today. So those things will come. So now here I listed out AWS. AWS infrastructure, it is very simple because AWS has its own, not only AWS here, we have so many things are there. Azure Cloud is there, Google Cloud is there, so many clouds are there. So there already predefined templates are there for infrastructure. If I want 20 servers with similar infrastructure, just only I should create only one infrastructure. Then I'll put a small script in cloud formation thing. We'll see that one. So automatically it will build based on that. It will build multiple servers. That is the one automation tool. Similarly, Chef. Nothing but configuration management I have. One tool is another tool, Chef. Of course, we have so many are there. Chef is there, GitLab is there, SVN is there, Collaborate is there, and Visual Studio source code is there, it's the old one, and TFS is there, Team Foundation Server. All these servers, nothing but actually, we can store the code. And then configuration management. Configuration management, not only the code, okay. There I can put few condition automatically, coding standards or warnings. If I'm checking any code file, how many warnings can be allowed? Only max 1 or 2. I can configure that. If any error is coming, I can throw there itself. I don't want to commit the code there itself. Okay. If any conflict is coming, I don't want to allow them to commit the code in my server. Suppose if warnings I'm getting more, naming standards. Suppose I want to use some class name CLS underscore the name, but somebody use class, full class and then name, or somebody using login underscore CLS. They put CLS at the end of the class. So all this configuration, but as per design, as per the author's given standards, I should use CLS class name, example. In that case, I can configure all these coding standards and then not allowed to the developer team to check in automatically if the standards are not meeting. I will reset there itself. So what happening in this scenario, I don't want to spend much time again on the review part. Otherwise, I have to spend again the time to review. Coding standards followed each and every person or not. So one person can write thousands of lines of code. So each line may take 1 second. If I'm spending 1 second per line, so 1,000 lines with 1,000 seconds I have to spend. So if I put all these configurations in the configuration management, I don't need to spend this 1,000 seconds itself. Likewise for each member. So avoiding those things. So those are, we have a lot of tools are there automatically reflect the servers, and then also it will give the quality of the developer. It will give the report of the developer. I no need to verify how much quality is there during my appraisal time. Appraisal time, people will write, I did excellent quality, I did never received any bug. But I can generate a lot of reports as a manager, as a lead, based on this. Check configuration tools and every tools. Who checked in how many times is rejected from this developer. So it speaks the truth there. Even though I'll write like I did excellent coding and never received any bugs, or I received only 10 minor bugs. There is no major bugs. All those things I'll write. But while I'm reading, I'm giving rating to you 5 or 4, 3 or ABC I have to give. That time I cannot remember because I'm doing a project for 20 members. I cannot remember. I cannot verify Excel files also maintaining. So what I'll do, I'll generate in front of you these reports. This is what happened with respect to your coding. This is what happened with respect to your the coding bugs. So tools will speak. It won't allow to bluff anybody. It is pure transparent there. And similarly, we have other tools, performance management tool, nothing but okay. This is what actually real-time process. How much is to process? Somebody say performance-wise, okay. I download one report. My report is maybe taking 10 minutes. Example in production. Customer saying, boss, I'm generating report is taking to me minutes. I'm expecting to seconds. Okay. And during my testing, maybe taking 10 seconds because I have less data. But production, I have millions of data. So there also we can put monitoring why it is taking more time. It's because of connectivity of the data or building the data, all those things. So we have app dynamic tool is there. This tool collects actually all the code and fixing the errors of the, including the resource level, CPU resource level, which suppose I'm logging taking 1 second. Once I log in, suppose I'm filtering the data of the products in Amazon. I want only Apple phones or some smartphones with 4 GB RAM, 64 GB RAM, but it's giving lot of time. It's taking a lot of time to display the product days. Login taking only 1 second, but the product is taking a lot of time. Similarly, if I use search condition, I want to see the TVs. Maybe TVs getting fast products, but what is happening with respect to phone search? Those kind of that level of the errors will get it there. Errors not with respect to only runtime errors. Errors could be anything. It can be resource level utilization, it can be display level utilization, it can be rendering of the application, or it can be anything. It can be the connectivity between the network issues, latency of the network. And we have continuous monitoring, of course, those are for the servers as well as any server is going down or what is the health checks of the servers, all those things. So everywhere by sitting at home itself, I can monitor entire thing because everywhere I can generate reports. I no need to go see the log file. Sometimes what will happen, who is maintaining servers, if I ask somebody, development team asks logs, where are the logs are there? They will go, the logs itself will take time for to get. It will take minimum 1 week to me get the logs sometimes, or sometimes it will take 3 days. So I have to wait for 3 days to verify where it went wrong. Is it a problem with the server? Is it a problem with my code? Or is it a problem with the network? No, I don't know. A lot of people again involved. I'll say as a developer, my code is working. Problem with the network. Network team says, yeah, bandwidth is fine. We tested everything. It is coming like 100 Gbps. Now, server team say, no, my server is working fine. I have 64 GB RAM, 2 CPUs, 2 cores, and then have 100 GB SSD. Then where is the problem then? Is a problem with integration? Everybody saying every individual is working fine. So I will get mad by saying all these things if I don't do. So the app dynamic and other tools are there. So I can see where is went wrong by sitting at one place. I can verify is a problem with the development, is problem with the operations, problem with servers, problem network. Reports automatically generate. So DevOps is nothing but actually implementing of these tools for different processes at different phases of the release process as well as the entire life cycle. That is what called actually DevOps. DevOps tools. DevOps is one process, enabling the tools for each process for each phase of the life cycle. Of course, we have so many tools. Different tools are there. Each tool has this own purpose, and each tools will have some are maybe with respect to project management tools, some are with build tools, some are with configuration tools, configuration management tools, some are for deployment tools, some are for some server mounting tools, logs mounting tools. Everywhere we have to integrate. That is actually DevOps. End-to-end DevOps nothing but actually integration between all the tools, right from requirement gathering till the go live to the end users. In some product companies, once it is deployed into production, automatically one email will goes to end users, not to IT team, not to the directors of the company, end users of their customers. Boss, we deployed so and so patch today with the release of so and so fixing. If you say we'll have Windows security patches, correct? Best example I'll tell how DevOps is working. In Windows itself, we have updates. Windows updates are there, and then security patches are there. Once I restart, it will say some patches are getting updated. You want to continue deploy, or only download now. Later you have to deploy. So steps are there. Or I'll say I can say download now. Later I can deploy, because if I deploy, I have to restart sometimes Windows. So who is pushing that to my Windows? How will I'm getting that? I'm not doing that as a person. First, I'm using Windows my laptop. Microsoft is pushing these patches. From where they're pushing? Once they build the security patches, some KBs and some updates on Windows, automatically it's going to all Windows servers or Windows application, including laptop servers. You have new patch. The patch fixes this is a release note. And it is saying you want to deploy automatically. Communication is also coming there automatically. That is nothing but a best example of the DevOps I can say. Without knowing us, is implemented long back. DevOps implemented long back, not now. Only pay came to picture recently for the application point of view and testing point of view. But this was there long back, the process. Now here a lot of tools are there. Few tools for the .NET depends upon technology also. Depends upon the how much effort. Effort nothing but here money. Some people will say I don't want to spend much money on DevOps, but I want DevOps. Okay, go for open tools, but you may not get the all support, but few things you need to develop your own things. Take example Bamboo. Bamboo may be costly there. Okay, Jira is there. Open Jira is free for 5 members. You can use for the test. Right now, from the requirement till the all the stuff. Eclipse is free. GitHub is free up to some extent, not completely. Okay. Similarly, load runner. Of course, I didn't put load runner. Testing tool. Cast is there. But if its cost is there, I cannot afford. So what tool I can use for the free tool for performance loading? Dynatrace is there. Or can I use Dynatrace for the performance testing? So many are there, kind of tools. Slack is one tool actually, communication between collaboration. Communication collaboration between the multiple teams. Like how we are doing for the WhatsApp chat, similarly Slack as well as Skype. So many other tools are there. Microsoft Team, free tools are there with respect to your using. Maven is one tool. Most of people using Maven, Jenkins for Java. Of course, Maven for use we can use for other purpose also. Similarly, Bamboo can use for all technologies, and Splunk, Puppet Shop, everything, every purpose, every tool has every purpose. The most important for DevOps engineer is how to integrate these tools. How to integrate these tools. That is a DevOps engineer responsibility. DevOps engineer no need to know how to develop code, with respect to any technology. DevOps engineers no need to know how to write test cases using Selenium, how to write test cases with respect to anything. DevOps engineers should know how to build a platform with, using the most of the tools and how to integrate between these tools. That is the DevOps responsibility. Now, once you've done this, automatically what is happening here is you will lose the confusion between parties. Both will become like friends, and the movement will be fast. The movement nothing but it is very fast with respect to your production deployment. Automatically, without knowing you, production will deploy packages like this. Like how we are deploying without knowing us, we are deploying a lot of patches every day in this laptops itself, which is pushing by the Microsoft. Not only laptops, for the matter anything. If you deploy any software, it will automatically it will open. Once it opens, it will say update version is there. Do you want to deploy it? That message will get. Even if a Notepad plus also will get it. So this is how DevOps will be have 7 concepts actually: communication, collaboration, control process, continuous integration, continuous testing, deployment, everything. All 7 C's will get the happiest path within seconds. I'm telling within seconds. To have all these 7s, it takes minutes and years or sometimes weeks also. So within seconds, it will done if you are becoming implemented DevOps. Any questions so far before move to the demo? I'll show one demo quickly. Any questions, we can open up for the questions, okay? Let me go to the, yeah, go ahead. I'm showing here a simple example of AWS DevOps. See, DevOps can be implemented in the cloud as well as on-prem, depends upon the tool choosing. My local server, local laptop, I can implement it in cloud also. Similarly, I can implement code repositories. Code repositories also I can implement in the cloud, I can implement my local also. Similarly, automation testing, test scripts, everything I can implement local as well as I implement cloud. I'm showing one Amazon AWS one. Okay. Let me log in here. Okay, this is actually AWS one. I said a software. Yeah, go ahead.
Sir, your screen sharing is stopped.
Oh, is it?
Yeah.
Sorry.
No.
Is it coming now?
Yes. Yeah,
Yes,
we are able to see.
Yeah.
I think I logged in actually, AWS. So let me log off and again. This is AWS. I create only one account, just I'm logging. Okay. It will ask user ID and password. Once we created it, it will ask user ID and password. See, this is why when I created GitHub, I created my own. GitHub here. I have so much of code here, which only I can use anywhere. Once I checking the code, automated deploys will happen. But today I don't want to show that part because we have only for 3 to 5 minutes max. Let's see it. What I'll explain. See, here I'll explaining in AWS, a lot of concept is there in AWS. I'm just giving overview of the cloud of AWS. AWS has easy to install nothing but actually hardware services I'll go. These are all services building giving by the AWS in the cloud. Different services are there. One is the hardware services, one is the storage services capacity, and then another one is analytics services. So many services are there. At the same time, here we have managing and governance. See the cloud watch is there, different cloud trail, different are there. These are all nothing but actually monitoring my servers and then health. See health dashboard and then architecture verifications, app configurations, systems configurations, service operation configuration. So many are there. CloudWatch, of course, will have end-to-end. And at the same time, security, is it breaking security wise? Anything. So different services we have, database services, AWS. But mainly we'll use EC2 services. EC2 nothing but actually system. It is a kind of VMware. Okay. So VMware nothing but if you see here, launch instance I have, correct? Just I'm showing one DevOps here, nothing but infrastructure as a source. Code as a infrastructure as a code I'm saying. Automation, building the servers I'm showing here. Okay. See, they build so many servers here. They build, this is one Linux server with these softwares. The software has the glib, GCC and build tools and so many are there. This image has actually MySQL, PostgreSQL, PHP, Docker. See, Docker is one of the actually tool for DevOps. Okay, Docker image. Similarly, this image has so many other stuff. So it depends upon the technology and these things. So they build actually different servers here. These are all called actually platform as a service. If you see, this is they're giving for me complete development platform for Java, including the database, everything, and Python. I don't need to install anything. This is a platform as a service. So Amazon built one platform for me for development Python code or Java code, including database. And this is actually free is there, of course. One, this is done right. One, this is created. I don't want to create now. I'll show already a created one. We'll see during the courses how to create all these things. So many servers are there. Depends upon your requirement. It depends upon your software. What we need, we can see. See, deep learning AMA, another one. I can use this is only for the DevOps. This is only for the DevOps actually. Okay. And depends upon other softwares we can use. Okay, let's move to the EC2. Once I build EC2, I'll have my running server here. This is what I built. One server. The server is nothing but actually this is public IP and then Linux server, everything we can see actually. This is what Amazon AMA used actually. AMA nothing but actually what is their 64 GB RAM. I can see the details here. 8 GB of the image size, public IP addresses, all the stuff I can see. So many things we can see here. Okay. Now infrastructure as a service. So suppose I want to use the same server to build my production environment like 20 servers or 10 servers. What we can do is if you see here, launch configurations, auto scaling and launch configurations is there. Auto scaling nothing but actually, of course, that is again Amazon concept. Suppose I want to use this same server. Whenever my this server is getting 95% usage. Okay, that means whenever this is going peak, that time I can go actually, I can create a group auto scale, then I include this server, and then I can adjust the capacity here. Automatically provisioning will happen. That means whenever the server is utilizing more than 100%, I can create immediately another server. Create auto scaling group. I create the group here. Okay. And then I can create the same image. What image you want automatically. See here. This is automatically I want to create. Okay. But another way of creation also is there. Nothing but another way. Because I already created one. I don't want to select anything, correct? So what we can do is we can create this snapshot of this same thing. I can create here. I can take the snapshot of the same thing. create image. See here, I can create the same image, and then I can use the same image. Okay, I'm giving the image here. Now I created image, correct? Once I create the image, of course, takes some time. Once I go here, auto launching here. Auto launching here and create here. I can select here my images also. Community images are there, and then workplace images are there, or my image, nothing but actually which is created. Just now I created, right? Test image, correct? I can select this one, and I can say when this can be used. Okay, these are all nothing but actually steps to involve all the stuff. Of course, I need to create all these things. This is one way. And let me go to quickly how we can use actual DevOps in EC2, AWS. See, in AWS, we have developer tools here. Code start, code commit, code deployment, code deploy, code pipeline. These are all nothing but DevOps tools. If you see code pipeline is nothing but end-to-end, right from taking to the code till the deployment of the code. See, source control. One is the code commit one. I can start and give the repositories, and code build. I can use actually code build, what code base I can use and everything, and code deploy. Finally, code pipeline, nothing but actually how it should be works. Once if I get started my code commit or code pipeline, 1 second, lot of things I'm getting. Yeah, let's talk about any questions. Anybody have any questions? I'll just open for any questions. Hello? Anybody have any questions? Your voice is breaking. Yeah, low voice. Can you be a bit loud?
Yeah, now it is fine.
Yeah, very good. Yeah, it's fine.
Yeah. So may I know what are the topics we are covering, for this training?
Okay, see, it depends upon the course. We have courses here. The courses, nothing but we have courses only for DevOps, nothing but only on-prem data center DevOps. Or if you want to cover, if you want to do, if you want to take for the AWS as well as the DevOps together, courses are different. If it is AWS and DevOps, we'll cover the AWS Cloud Practitioner one, minimum details of the AWS services, and we'll take all the tools with respect to Jenkins or with respect to any tools. All the tools, including build tools, testing tools, end-to-end, will explain in the AWS. If you're opting for not AWS but only DevOps, we'll use different tools there. Tools in the sense we'll use Jenkins, we'll use some testing tools, build tools, and configuration tools and deployment tools. But those are all within your local laptop, within your actually on-prem.
Okay. Yeah, got it. Yeah. Okay.
We are covering end-to-end delivery with respect to DevOps, but whether it is cloud, whether it is non-cloud, that depends upon what course you opted it. We have both courses.
Okay. Yeah. So we have here we are supporting AWS, or do we have any Azure or the Google Cloud also there here?
We are not supporting Google Cloud. If somebody wants Google Cloud, more members comes, we'll do it. Depends upon the batch. We cannot do one-to-one these kind of things. See, if Azure is coming, everybody like one group, 5 members, we'll start Azure. No problem. Everything is open actually. We can.
Okay.
But in one course, we don't cover all. We cover only one cloud in one course.
Okay.
Because services are different and then configurations are different. People will get confused.
Yes, yes. Yeah, I got it.
But
Yeah,
the thing here is, if anybody opting anything is concept is most important, because this is a process, yes, right? The
correct.
tool depends upon industrial, what are the tools in using industrial. We'll choose those tools. Couple of tools for each process we'll choose, and then we'll start building and
Yes.
explaining with respect to different things. Yeah.
Yeah.
But once you learn one tool end to end, the same concept will be there other end also. It is kind of one language different. If you know Hindi or Telugu, how to speak, the same thing we know how to speak in English if I know ABCDs. No need to
Yes.
worry about again building the sentence there.
Yeah. Okay. And
Same concept.
yeah. So, but while creating a pipeline, we are just doing manually, or we are doing, we are using any Groovy script like that, Groovy code, anything.
Everything automatic.
Yeah. How we are doing means here means in training.
Depends upon what build tool used.
Okay.
Okay. Suppose if I use build tool as Jenkins or something, Maven.
Okay.
Okay, scripting may be different. If I'm using build tool as a web application, .NET web application example, build tool may be different there because that runtime should be there.
Yes. Yeah.
So depends upon the technology and the tool. We'll explain each technology one scenarios. One .NET, one Python, one Java. Major technologies, not all technologies. What tool we integrate and what. Okay, suppose again that depends upon the what I use the source control. If I'm using GitHub source control, GitHub again in the cloud, correct? I
Yes.
can
Yeah.
give GitHub URL as it is for my the source control of the building. Whenever changes happen on the GitHub, okay, so automatically build will happen. Suppose if I'm not using GitHub, if I'm using some TFS or some other as a source control, okay, some other as a source control. In that case, I'll use different one.
Yes. Yeah. Got it. Yeah.
Okay.